Hello everyone, in this video I'm going to be talking about how to install an halogen on a benzene ring, or how to how to do an electrophilic aromatic substitution reactions using halogens on the benzene ring here. And typically you could use Cl2 or you can use Br2. Those are typically used, and the catalyst that you're going to be using would be AlCl3 or FeBr3. You could also use AlBr3, and you can also use FeCl3 as well. Your end product in this particular case is obviously going to be you are replacing the hydrogen and installing the chlorine there. So if you have Br2, then you would be installing the Br there instead of the chlorine, but that's going to be your final product. Now, how does this really work? So let's talk about that. So first of all, you got to worry about what's my electrophile going to be. And the Cl2 itself is not a strong electrophile, but you can make it a stronger electrophile if you have an Lewis acid present. So that's what we're exactly doing here. So I got this Lewis acid here, the AlCl3. So in the first step, I'm going to be having the chlorine lone pair attacking the aluminum. So I get aluminum with a negative charge. I got a positive charge on that chlorine, and the chlorine on the left stays as it is. So now having a positive charge on the chlorine that's right next to the aluminum makes the chlorine that's on the left side even more electron deficient, because of the inductive effect. They're going to start pulling the electrons on that bond between the two chlorine atoms onto the chlorine with a positive charge, as a result, making this chlorine even more electrophilic. So that's going to be your electrophile in that particular case. So once you have done this first reaction, the second reaction is going to be using your aromatic ring and using your electrophile that you have created and doing the nucleophilic attack here. So this is going to do the nucleophilic attack here, and then this is going to chlorine bond is going to break to make the AlCl4 1 minus. So AlCl4 1 minus is going to be your intermediate there, or side product here, and then obviously you're going to have chlorine attached. So I'm killing one of the pi bonds. So I'm going to be having chlorine there, and this carbon gets positive charge. And then eventually you want to make sure you can draw the resonances on this. So I'll draw that on the bottom here. So I can have this move down here. So when this moves down here, let's see what that resonance structure is going to look like. Kind of positive charge here. And then this comes down here. So these are your resonance structures. And then eventually I'm just going to go ahead and draw it from here. I'm going to have the conjugate base that I've created. So AlCl4 there with a negative charge. So I'm going to using one of those chlorines to remove that hydrogen. So it grabs this hydrogen, and this goes in there to create the pi bond, so that restores the aromaticity. Got a double bond there, and then HCl is going to be your side product. So a lot of times these reactions are going to be worked up with a base just to kind of kill that strong acid, but then this is going to be your main product. And if you were using Br2, then you would have a Br installed, but the reaction mechanism is going to be more or less the same. So before I go, I do want to talk about, how um, halogens, if you have a halogen on the ring attached, so that's going to be either chlorine, bromine, iodine, or fluorine. They are electronegative, so through inductive effect, they are electron withdrawing groups, but they still do ortho para attacks, and that's because of their resonances that they can make. And why they can make a resonance is because they got lone pairs of electrons, so they can be donating in the electrons to the ring, making them making the electron making the ring electron rich. As a result, you're gonna have the negative charge at the ortho and the para position. So this is something I already talked about. I just want to briefly mention it, but the main focus on here was just the halogenation of aromatic compounds where you can use either Cl2 or Br2 in the presence of amylose acid. If you have any questions, feel free to leave any comments in the section below.